Graphing logarithmic functions. Our objective: graph logarithmic functions and note their basic characteristics. So what do we already know? We know what a logarithmic function is. Any function of the form f of x equals log base b of x, where the base is greater than 0 and not equal to 1, and the argument, is always greater than 0. Okay, we're going to use a graphing. We're going to use Desmos to graph these things and take a look at their characteristics. So example 1, use a graphing device to graph the logarithmic function f of x equals the log base 10 of x and sketch the graph. So this is a base that is greater than 1, and let's pull out our Desmos. Okay, and it looks like I've got a previous example in there, so let's get that out of there. Whoops, there we go. And I want to graph it. The log is under the functions menu over here. So y is equal to, and go into functions, and you need to scroll down a little bit until you find log. And here's natural log. We'll take a look at this later. This is the common log, which is log base 10. This is the log with any base you want. I'm going to choose this one, and it allows me to input the base, and I'm going to put 10 in there because we've not discussed the common log yet. And then inside is the variable x, the independent. So here's log base 10 of x, and I should have the graph, but I'm going to press the home key, and here it is. And you can see the graph. I'll touch that point there. That is the x-intercept, which is 1, 0. And you can see it's coming up quickly. If I go a little bit like that, it grows very fast at the beginning, and then it's crossing the x-axis at 1, 0. And then the growth is slower and slower and slower and slower as the x values increase. It's still growing, it's just growing very, very slowly. So let's put that on our paper. Okay, let's take a look here. We were dealing in quadrants 1 and 4. So I'm going to kind of draw my graph like this. So there's my x-axis, and this is my y-axis, or my f of x axis. And we saw that it crossed at 1. And what happened was it's really coming up quickly, but it hits 1, and then it still grows, but the growth is slower and slower and slower. So this is the graph of f of x is equal to the log base 10 of x. And again, rapid growth at the beginning, but the growth, it's growing slower and slower and slower and slower. So the growth is slower and slower. Okay, as it starts down here, it's growing slower, not growing as fast, not growing as fast, not growing as fast, not growing as fast, etc. It appears to level off, but it never does. It just continues to grow. It just that growth is going slower and slower and slower. It never levels off, but it certainly appears to do that. Example number 2, we're going to do the same thing, only this time our base is going to be 1/2, a number between 0 and 1. Okay, so let's go back to Desmos. And I can probably just use what I have here and tap it in there and hit the base, and I'll delete the base, and I'll put in a 0.5, which is the same thing as 1/2. And here's this one. And so you can see with this graph, in my case it's in blue, let's say the decay, I guess, or the growth is, I guess it's decaying, isn't it? And it's decaying slower and slower and slower and slower. Again, it's crossing the x-axis at the point 1, 0, and it's not ever touching, there's no y-intercept, it's never touching the y-axis. The y-axis is a vertical asymptote, So let's graph that one. Let's just sketch that one. Let me get this out of the way here. And again, I already know we're talking about quadrants 1 and 4. Whoops, that's not a straight line. That's a little bit better. I'll go out like this, and this is my x-axis, and this is my y-axis, or my f of x-axis. And it came down from above, and it's decreasing, but the decrease is slower and slower. It crosses the point at 1, the x-axis, and it's still decreasing, but the decrease is slower and slower and slower. So this is f of x, which is the log base 1/2 of x. And so the decrease is slower and slower. Again, it's still decreasing, and even as it goes out to positive infinity, it's still decreasing. The y values are still getting smaller. They just get smaller, slower, and slower, and slower. So let's take a look, and let's wrap this up with a picture of both together and some common characteristics. Okay, the logarithmic function. Here's our base equation, y equals the log base b of x. We note that it has an x-intercept. It's at 1, 0. We can see it in both the increasing example and the decreasing example. The y-axis is a vertical asymptote. It's a vertical line that shapes the graph. It never touches the y-axis. It gets closer and closer and closer, but never touches. The domain, well, it only works for positives. The range is anything from negative infinity, all the way to positive infinity. And again, yes, we have here the vertical asymptote is the y-axis. But those are the graphs of the base graphs of the logarithmic function. This is the one that tends to get more use when you have growth that's taking place, but is growing more and more slowly over time, more and more slowly over time.